All right, guys, welcome back. Lesson 11.2, day 3. Now we're going to revisit our memory training that we did when we tried it in class, and we did a matched pairs where you tried one memory trained activity or strategy and then tried another one to see which one did better for you. So this is the same idea. So we have 32 seniors that were randomly selected to try memory strategies. Each student calculated the difference in the number of words, strategy 2 minus strategy 1, and the mean of the differences was 1.5 with a standard deviation of 2.7. Do these data give convincing evidence that strategy 2 improves memory at the alpha 0.05 significance level? So it's the same setup as before. So this is a matched pairs because it is the intervention is being done to the same person, just in different orders. So that's a matched pairs. And whenever you have matched pairs, you're really looking for the mu diff. You don't want to do mu1. You don't want to find the individual means and subtract them. We're going to subtract them and then find the average difference. Okay, so our parameter is not mu1 minus mu2. It's mu diff. And the mu difference is the true mean difference in words remembered. So the true mean difference in words remembered. All right, so our statistic that we're interested in is what is the actual difference. And the actual difference they told us in the problem is 1.5. They told us that's going to be at alpha 0.05. So our hypotheses, this is a good place to pause, see if you can write the hypotheses as they should be, and check them with me. All right, so our null hypothesis is that the mu difference, meaning the average difference, is 0 because there is no difference. And your alternative is that the mu difference is going to have to be greater than 0 because they are asking specifically that strategy 2 is better. So if we're doing strategy 2 minus strategy 1, for this to be better, it'd have to have a bigger number, which means the differences would have to be more than 0. So we're going to go through our plan section, pause here and give it a try on your own and come back and check it once you're done. So the name of our procedures, because we're doing a mu diff and we're only looking at the differences, this is a one sample. T-test for mu diff. Okay, so our conditions, we have random. We had 32 randomly selected seniors. %% rule is not needed. Why is it not needed? Because we did random assignment. All right. And then our last one is normal. Our n equals 32, which is greater than or equal to 30. So the central limit theorem comes into play here. All right, so our mean. The mean is our claim. We're saying that there is no difference. Our standard deviation, we got to take the sample standard deviation divided by the square root of n. Sample standard deviation is 2.7 divided by the square root of 32 for our sample size, and I got 0.477 there. General formula to get your test statistic, which in this case will be a t-score. You're going to take the sample difference, so x bar diff minus the mu diff divided by the standard error that we calculated before. So what it looks like in symbols is t equals x, well, that's what we just did, x bar diff minus mu diff divided by the standard error. So our numbers are 1.5 minus 0 divided by 0.477. Okay, these are all the numbers we had already calculated. And when you calculate that all out, we get 3.14. This means that is more than 3 standard deviations. The results that we had were more than 3 standard deviations above the mean. So we can pretty much guarantee this is going to be a reject scenario because it's so far away from the mean. So our t-score is 3.14. When we draw this, we're going to make our t-distribution. We said there was 0 difference. We got 1.5 for our score, so we're looking for this area right here. Our t, our degree of freedom, is going to be 31, but we have to round down to 30 to use the table. So we'll do that. And so let's look. We got a t-score of 3.14 with a degree of freedom of 30. So we're going to go to 30 and go all the way over. So it's going to fall between these two lines right here. And that's between 0.001 and 0.0025. 0.001 to 0.0025. All right. So what does that mean? Pause here, write a conclusion, and come back and compare it. All right. So the conclusion, fully written out the way it should be, assuming there is no difference in the number of words remembered using different strategies, there is a 0.001 to 0.0025 probability of getting a sample mean difference of 1.4 or more purely by chance. Because our p-value, 0.001 to 0.0025, is less than alpha 0.05, we reject the null. We have convincing evidence students remembered more words using strategy 2. Make sure you put your context of, if you're rejecting the null, what does that mean for your alternative? All right, now our summary of our notes for today. Here's our 2 learning targets. The 1 learning target was calculating the test statistic for mu diff. Here's our formula that we used. Another thing to remember is when you draw it, we had this on another one, but I want to draw it again. We had a difference of 0. You figure out where your line would fall, and this is going to be, it's not normal, it's a t-distribution, degrees of freedom. And then deciding if it's 1 sample or 2 sample. We discussed this last unit, but I wanted to give you some more practice, which is going to be your understanding for today. 1 sample or 2. If it's 1 sample, that's a matched pairs. That means the same people are being tested and maybe the order of the test is being given, or 2 nearly identical people are being tested. And when that happens, you're going to subtract and then find the average. You'll only have 1 mean to work with. If it's 2 samples, you have 2 independent groups and 2 means. You're going to find the average of each and then subtract the means. So think of this while you're trying these check your understanding questions. As always, if you have any questions, please feel free to email me. When you finish your check your understanding, take a picture and upload it to Canvas. Talk to you later.